So here's a nice Fermi question to look at. It says, how far apart are the average molecules in air? Well, it's kind of an interesting question. There's a couple different ways to approach it. The way that I've chosen is I know that there's one fact that I remember from when I learned about what the concept of a mole is. So I know that 1 mole takes up 22.6 liters at standard temperature and pressure. So if we have 1 mole of molecules, and I know that 1 mole of molecules has Avogadro's number of molecules, 6.022 times 10 to the 23 atoms per mole. So knowing these two values, the 6.022 times 10 to the 23 atoms per mole, and I know that 1 mole takes up 22.6 liters, I know that 22.6 liters over 6.022 times 10 to the 23rd, so this is liters per mole, and this is atoms per mole, which means this value is a volume per atom or per molecule. So if I were to take these values, divide it out, I know I get 10 to the negative 23 on top, so our volume is 10 to the negative 23 on top, and 22.6 divided by 6, I'm going to say this is approximately equal to 4. So 4 times 10 to the negative 23 will give me my volume, and I know that my volume, if I assume these are little boxes, is nothing more than one of the dimensions cubed. So if I take the square root of my volume, that's going to give me the average distance between the molecules, which works out to be approximately square root of 10 to the 22. This is going to work out, or square root of 4 times 10 to the minus 23 works out to be somewhere around 3 times 10 to the minus 9 meters. There is one conversion that I skipped in here, and that it's this is in terms of liters, and I know that 1,000 liters takes up 1 cubic meter. So there's an extra factor of 1,000 in there. But it works out to be a nice little number. It's around 3 times 10 to the minus 9, or 3 nanometers. So the average distance between any given molecule and area is on the order of nanometers.